Welcome to the Mahatma Gandhi Institute of Technical Education and Research Center. In 2004, a national level institute MGITER has been started in the field of engineering and technology as per guidelines of All India Council for Technical Education AICTE New Delhi. MGITER is approved by AICTE New Delhi, Gujarat State and affiliated to Gujarat Technological University Ahmedabad, which is also known as GTU. Our goal is to be an institute of generative ideas so that we remain relevant to our society. The MGITER has always been an organization on move with continuous effort on improving its processes and to maintain its relevance to the Indian science scenario, with adding new programs in its programmatic portfolio. We strongly believe in overall development of students, so for that we provide them a different platform like state level tech fest, project fair, different sports activity, which helps students to teach teamwork and problem solving skills to get physical health benefits, boost self esteem, and reduce pressure and stress for prove their skills in distinct area. This is virtual class of Professor Gaurang Patel for the subject design of AC machine. In this video lecture, we will going through the contents like shapes of stator slots, factors deciding number of slots, and stator slot pitch. So one by one I will explain all those contents which are also asked in GTU examination frequently. So now we will see the shape of stator slots. So mainly there is a three types of slots in three-phase induction motor. Uh, First one, that is the open slot, then semi-closed slot and closed slot. Okay, all types of slots will use according to the requirement of three-phase induction machine. Okay, and the shape of slot has an important effect upon the operating performance of the motor as well as the problem of installing the winding, because the slots may be completely open or semi enclosed. We can see in shown in figure. Okay, when open slots are used, the winding coils can be formed and insulated completely before they are inserted in the slots. Also, the windings are reasonably accessible when individual coils must be replaced or serviced in the field. And then, on other hand, we can say the coil must be tapped and insulated after they are placed in the slots for machines with semi-enclosed slots. The semi-enclosed slots, that this is the semi-enclosed slots. Okay. Well, for the induction motors, it depends on the use of their air gap contraction factor. Okay, if it is small, then value of magnetizing current will be small. Okay, the use of semi-enclosed slots result in low pulsation loss and a much quieter operation as compared with the open slots. What I want to say that what is the advantage of semi-enclosed slot in case of open slot. I will explain you once again that the use of semi-enclosed slots, that is the semi-enclosed slot, the use of semi-enclosed slots result in low tooth pulsation and a much quieter operation as compared with the open slots. Okay, therefore open slots equal to slot opening equal to the width of slot are used where it is desired to complete the coils outside the armature and drop then into the slots. Incidentally, an advantage of open slot is that their use avoids excessive slot leakage, because whenever we are going to use the open slot, it will useful for us to avoid the excessive slot leakage, thereby reducing the leakage reactance as well. So you can understand where we can use the open slot, where we can use the semi-closed slot, and where we can use the closed slot. Okay, So next we will see some of the important statements regarding the shape of stator slots. Okay, so we can see here the first statement says that the shape of slots has an important effect upon the operating performance of the motor as well as the problem installing the winding. Okay, and the next one that says that semi-enclosed usually preferred for induction motors because with the use the air gap contraction factor is small and value of magnetizing current will going to be reduced with the use of this semi-enclosed slots. Okay, here we see the design of stator. You can see here there is mainly 5 factors which affecting the choosing the number of stator slots. Okay, the first that is the tooth pulsation loss, second one that is the leakage reactance, third one that is the ventilation, and fourth one that is the magnetizing current, and fifth one that is the cost. So one by one point we will see in my explanation so you can understand it better. So first of all we will start with the tooth pulsation loss. So what is tooth pulsation loss? Tooth pulsation loss there is in motors with open type slots. The slot openings have a considerable influence on the air gap reluctance. So what we consider in last slide, there is a 3 types of slots are there. So if we use the open type of slots, so it has a considerable influence on the air gap reluctance, and this air gap reluctance is very important in this design of AC machine. It is a very it will play a very important role. Okay, so now the slot should be so proportioned that minimum variations in the air gap reluctance and produced because it required the minimum reluctance. Okay, so the effect of this variation is to produce torque pulsation losses and noise. Okay, so due to that variation of air gap, the tooth pulsation losses and noise will be there. So these effects can be minimized by using a large number of narrow slots. So if we found this kind of problem in DC machine after designing it, so we can solve the tooth pulsation loss with minimized by using a large number of slots. Okay, the next one that is the leakage reactance. The second point it is considered the leakage reactance. So what we are here discussing, we are discussing the factors deciding number of stator slots. In second point there is a leakage reactance. So what is leakage reactance and how it will be affected on the parameters of design of machine? We will say of leak. Look, if there are large number of slots, there are large number of slots to insulate. Okay, if number of slots are more, so we need the more insulation. Okay, so therefore the width of insulation becomes more and more broader. That means the leakage flux has a longer path through air which result in its reduction. Therefore, with large number of slots, the leakage flux and hence the leakage reactance is reduced. Okay, so in fact the slot leakage reactance is inversely proportional to the number of slots per pole per phase. With small values of leakage reactance, the diameter of the circle diagram is large and hence the overload capacity increases. Okay, so thus with larger number of slots the machine has a higher overload capacity. Understand that what I want to say, where with the large number of slots the machine has a higher overload capacity. So if we use the large number of slots, what advantage we will be get? We will get the higher overload capacity of the electrical machine. Okay, so next what we will see, now we see the third point, that is ventilation. Okay, so here, okay, first 2 points we already explained, this one tooth pulsation loss, and this one the leakage reactance. Now third point, that is the ventilation. So in design of three-phase induction motor, ventilation is play a very important role, because the main function of ventilation to provide the cooling the winding of AC machine. Okay, so in parameter of ventilation, the larger the number of slots for a given diameter, the smaller will be the slot pitch. If the slot pitch is small, the tooth width is also small. Okay, since width of stator slot is generally about 1/2 the slot pitch on the gap circumferences. Okay, so with larger number of slots, the thickness of the teeth becomes smaller, and the teeth may become mechanically weak, and they may have to be supported at the radial ventilating ducts by building T or I sections. Okay, so this obstructs the flow of air in the ducts, thereby impairing the cooling. Okay, so this is the part of ventilation or role of ventilation, which is effect in the design of AC machine. The fourth one, that is the magnetizing current. Okay, over here magnetizing current and iron loss we consider together. Okay, because it depends on each other. Now we consider the magnetizing current. It has been explained above that the teeth section is reduced. Okay, if the teeth section is reduced, the magnetizing current is going to be affected. Therefore, the use of larger number of slots may result in excessive flux density in teeth, giving rise to higher magnetizing current and higher iron losses. Okay, so the last one, that is the cost. Okay, cost, how we design the three-phase induction machine by cost effectively. Okay, so with larger number of slots, there are larger number of coils to wind, so insulate and install involving higher cost. Okay, if we use a larger number of slots in winding, so there is a larger number of insulation we are going to be used, so that kind of machine becomes a costly deal. Okay, so I hope you understand all those 5 points, that is tooth pulsation loss, leakage reactance, ventilation, magnetizing current, and cost, which are the parameters which is affecting the deciding number of stator slots. Okay, so now next what we will see the equation for the number of stator slot, which will useful when you are designing the machine, designing the sheet of a three-phase induction machine, when you have to select one factor, that is the number of stator slots. So we will consider over here, to select the number of stator slot, this equation. Okay, so this equation says that ES is equal to 4.44 F phi m TS kWs into 10 raised to 3. Okay, so that is the ES, that is the induced EMF in the stator, that is equal to 4.44. F stands for that frequency, particular frequency. Phi m, that is the maximum flux. TS, that is the number of turns of secondary. All those things are given over here. TS, that is stands for number of turns per secondary. KWS, that is the stator winding factor, which is usually considered the 0.955 for distributed winding. And how we will get the value of phi m? We will get the value of phi m, that is equal to average flux density into tau into the length of the diameter. Okay, and tau, which is we will be get by tau, is equal to pi d by p. Okay, with help of this equation we can find out the number of stator number of stator slots. Okay, so we will see the stator slot pitch. Okay, so over here, to consider the stator slot pitch, we have considered the equation, that is y-ss is equal to gap surface divided by total number of slots, that is equal to pi d by ss. Okay, so YSS, which is stand for the stator slot pitch. Okay, so for considering the stator slot pitch, what we will consider, that is the gap surface. Okay, the gap surface, that is equal to pi d, then total number of slots, that is SS. Okay, so total number of conductors which are including in that stator part, that is ZS is equal to 2 into 3 into TS. So the total number of conductor in that ZS, that is what, 2 into 3 into TS. So from that equation we can go to the total number of conductor per slot. ZSS is equal to ZS by SS is equal to 60S by SS. So this ZSS, that is stand for total number of stator slot, total number of stator slot and conductor, that is equal to ZS, that is stands for total number of conductors, and that is SS, that is stands for the number of stator slots. So total number of conductors divided by the number of stator slots is equal to 6 TS by SS. Okay, so this 6 TS comes with this equation, or with this multiplying this term, 2 into 3, that is equal to 6. You can see this 2 into 3, that is equal to 6 into TS, and those SS remain as it is. Okay, so that's how we can get the stator slot pitch when we design that particular problem. Okay, so this is the question asked in GTU. The question is, list out the factors to be considered while selecting number of armature slots in the design of synchronous machine, and explain any one, which was asked in summer 2019 and winter 2018. So regarding this question, if any query, you can free to ask. Okay, thank you.